Alright, so areas and volumes of similar solids. So like usual, similar solids are actually proportional. And when we work with them, we're actually going to call those the scale factors. So if the scale factor between two solids is A divided by B, or A to B, whatever, how you want to represent it, then the ratio of the areas is A squared divided by B squared, and the ratio of the volumes is A cubed divided by B cubed. And where do we get these A and B from? We actually get it from these A and B's. Okay, so if I know two shapes are proportional by 2 to 5 ratio, okay, and that's their scale factor, okay, then when I'm working with finding the ratio or the proportion I'm going to use for finding the areas is going to be 4/25, so this will be the area version, and then 8/125 in my proportion to find the volumes. Okay, all right. So for example, if I know the volume of, and now you can actually go backwards with that too. So if I know the volume of one shape is, let's say, 729 cubic centimeters, okay, and the volume of another shape is equal to 1331 centimeters cubed, okay, what I would have to do is just have to set it up. I know that that's going to be A cubed divided by B cubed equals 729 divided by 1331. Okay, now to solve this and to actually find the scale factor, I would have to cube root both sides. Okay. Now, some of you guys might be finding that a little bit hard to do. So when you put it into Desmos, okay, you're going to put 729 divided by 1331. You're going to raise that, and there is, I haven't found a cube root function yet, raise it to the 1/3 power. Okay, because if you do that, you'll actually get it. And what's going to happen is you're going to actually get the scale factor, which is going to be A divided by B. And that actually equals, I believe that's 9/11. There we go. I had to think about that and do my calculation real fast. So this will actually be the scaling factor of these two shapes just by knowing the volumes and knowing that they're actually similar. And that's the key between these two, is that you need to know that these volumes are going to be definitely similar. Okay. Okay. Smaller one. There we go. Okay, let's say the scale factor of two objects was 3/8 and the volume of the smaller one is 100 cubic feet. Okay, so what I'm going to do first is convert that from 3/8 to 27 over, let's see, 8 to the third, 512. Okay, so this is going to be one side of my proportion. Now the other side, I'm going to set it up as 100 over x. Okay, because obviously I want to find the volume. Well, not obviously, I need to spell it out. Volume of bigger solid is, let's leave it out as a question mark. Okay, so I'd set up my proportion to look like this. And what I would do is I would cross multiply. Okay. So I would get 512 which would equal 27x. Okay, and that's 51,200. So 51,200 divided by 27 is actually going to be 1,896.3 cubic feet. And that will actually be x. And so using this, usually people will go, oh, I used to do this back in the day when I was a student, was if I raise this to the third power, I must raise this to the third power as well, and that's got to be the volume. But you actually have to set up a proportion like this. Okay, and if you set up the proportion like this, it makes your job a whole lot easier. Okay. All right, and that's it for working with similar shapes or similar solids with areas and volume. I'll talk to you later.